collect, okay? So the section 2.4 is called acceleration. So what is acceleration? So we first go down. So ladies and gentlemen, now the language we want to use got to be layman's language. Why Obama is so successful? Because everything he taught in turn that regular people understand. They don't have too much technical jumble and mumble, but he can communicate. So in taking a physics class, don't learn too much deeply, but you can converting those highly technical terms into a language average people can understand. So we like to determine acceleration. Acceleration is again is a certain pattern we're talking about. It's called time rate. So change or velocity. So how simple that is? So you don't have to get into other terms. So now we want to point this out to you, ladies and gentlemen. If you look at all those famous theory, is simple term. F equal to ma in physics, right? E equal mc squared. All this kind of famous one is simple and then useful. It's not a double integral and triple integral. Okay, so we want to relate this to you so you can understand where we come from. So right away, A is time rate change of velocity, in which case it's delta V, delta T. Or you can say, suppose if it's along one dimension, if it's along x dimension direction, then you call one dimension acceleration. So if that is a one dimension, then you have a sub x equal to dvx dt. Okay, dvx dt. So because this is the general, so now we like to learn what we did learn Math Phi A calculus. We want to take the Math Phi A, start understanding it. So now what we like to do is do the integration. Okay, so we like to do the integration. In that case, is a sub x equal to dvx dt. Okay, so we separate them, dx dt and equal to dvx. So here we have to put some assumption. The assumption is very critical when you're doing something. So in here, v definitely is not constant in this motion. But we have to make the things simpler so that we can deal with. We can assume ax is constant. Assume ax is equal to constant. So now you have dvx equal to a constant should be involving this ax is dependent on time or not. Some of the motion that a sub x it do depend on time. So then when you do the integration, you have to take the time domain into consideration. So in this case, we like to do this again. We do the integration. So when you do the integration, you have to be aware of the variable, in which case is called boundary condition. Boundary condition. So in these cases, when you have to assume t equal to 0 at the time v sub x initially. And then if do another one, in which cases this is a v sub x, the final one. So now after you do the integration, then you have v sub x at minus v sub xi equal to ax times t. So ladies and gentlemen, we have v sub xf equal to v sub xi plus a sub x times t. The second one is important. So now we have to study another thing, little bit more. In which cases, what does this tells us? Okay, so we like to ask pictures, diagrams. What does it mean from the picture point of view? So now we are drawing the pictures. So we study the equations, study the statement. Equation is a statement of the relationship. The statement of relationship is v sub x f equal to v sub x I plus a sub x t. So now we want to converting what we're looking at into graph. So in their cases, we like to say, if this is it, then we have something like, what does the test tell us again? Okay, the slope of this line, this is the angle is called theta. Slope of this line, this is representative. This is the slope. The a sub x is the slope of the curve v sub x f versus t. That means if you have a velocity curve versus t, then any point at any location, the slope is the acceleration. So we extending further. So suppose you have a v sub x f curve like this. So somebody asks you, what is the acceleration? The acceleration is the slope. So what is the slope here? Slope is 0. So the association at this point is 0. So what is the association in here? Have a very fast association. So this curve is fast. So by looking at the graph, then you know what is the association, slow or fast. So what does the economy people look at? What does the stockbroker look at? Look at the curve. They're looking at the slope of the pond, and oh wow, this is the slope is high. Then that means the potential or the price changing is high. So the best time to buy the stock is at this location. If you look at the curve, and this location that is on the way up. The worst location is about this going down. So that's called. So the people is modeling the stock market by using this type of philosophy. So a lot of people say, you are a physics major, you're squarehead, you just understand what we call the stock market. Wrong. You can apply this kind of knowledge on different fields. Okay. So this is what makes you become a better person. So we are training you to be a better person. But you don't have to solve the most difficult problem in the world. Okay, this is this class. I don't want you to solve the most difficult problems. I want you to solve average problem. You don't have to solve the most difficult problem because let other people to worry about. We want to strengthen our understanding in physics. We can apply it in our daily life, in your practice, in your what you call in your career. This is what we're aiming at. So that is talking about acceleration. So looking at the graph, then you know what is going on. So now we want to develop a few important equations. about the motion. Basically, there's four different four equations are very important. So we developed one important equation, in which case is we just mentioned that v sub xf equal to v sub xi plus ax plus t times t. So we want to emphasize again on constant acceleration. So this one is on the 2.6 constant acceleration. The first equation we got is v sub xf equal to v sub xi plus a sub x times t. This is the first one. Okay, so now we want to move on to talk about the second equation. So the second equation we like to talk about is we like to draw this diagram first. This diagram indicates to us is this is v sub xi right here, and this is v sub xf right here. Then this one is t is here. So right here. Now we like to draw the diagram for the motion. So assuming this motion is along the x direction. So this is the velocity diagram, and now we draw the x. This is the x. So in these cases, right at this point, we like to say x sub I. Right at this point, we call x sub f. Okay, so we like to say that. So we say another point is what happened to in here. This is called average velocity. So this is a Pythagorean film. This is in the middle, and from the geometry and trigonometry point of view, if this is the middle of all, then this one is considered V average. So the V average velocity is equal to 1/2 V sub xi plus V sub xf. Now we go back to the original equation, original thing we're talking about. The average speed times time equal to the distance you travel. The average distance. So we like to say x sub f minus x sub I in this distance you travel equal to V average times t. So in these cases, we getting something very important.